Okay, here's our last topic for the week. We're going to work on solving systems by elimination, this time with multiplication. So there are a couple of ways that you can go about it, just really depends on the type of equation. So remember that elimination is used to solve a system of equation where you can look at adding like terms. So sometimes it might be necessary to multiply one or even both of the equations by a number. You can use this method. So you should look at them both really carefully and see which coefficients are maybe the easiest to eliminate. So if you look at this one right here that I have, multiplying one equation by a number. So the easiest one to work with here looks like x. Okay, so I'm looking here and I'm thinking, okay, if I multiplied these from a number, I would probably work with x and try to get this x to a 2, and then to eliminate them, it would have to be multiplying it by not just positive 2, but a negative 2. So I'm going to multiply the second equation by negative 2. You'll see what I mean. So I have, well, the first equation first, I'm just going to rewrite it. Now, if I multiply the second by negative 2, then I'm going to say negative 2 times x minus 3y equals, I have to do the same here, multiply it by negative 2 times 10. So then I get, I'm going to rewrite what I have up here. 2x plus 5y equals 9. Then when I use my distributive property, I have negative 2x. And negative 2 minus 3y. When I multiply those, I get positive 6y. And then here I get negative 2 times 10, I get negative 20. Now, I can eliminate them because that's what I just did. I multiplied them by negative 2 to eliminate. So now I have 11y equals 9 minus 20 is negative 11. So we'll divide by 11. I have y equals negative 1. So I could go in, plug it in. I could say 2x plus 5 times negative 1 equals 9. So I say 2x plus negative 5. I should have said minus 5, would have been easier. So then I add 5 to both sides to eliminate it. I get 2x equals 14, divide by 2, and I have x equals 7. So I have a solution here, which is 7, negative 1. I can do the same thing I've been doing, go back in, plug it in, make sure it works, and I positive it does. 7 minus 3 times negative 1, negative 3 times negative 1 would be 3. So 7 plus 3 is 10. So it works. And then we can even try this one as well to prove. 7 times 2 is 14 plus 5 times negative 1. So it's 14 minus 5 is 9. So that is a solution. Okay. Now, sometimes it's not going to be that easy where you can just see, oh, negative 2 would eliminate that. So sometimes you're going to actually have to do a little bit more and multiply both equations by a number. So what you would do for this set, we have 5x plus 3y equals 2. We have 4x plus 2y equals 10. So what you're going to do is you're going to find the least common multiple of 4 and 5. And hopefully you guys would know that the least common multiple of 4 and 5 is 20. So the least common of 2 and 3 is 6. So you're going to multiply the first equation by -2, and then you're going to multiply the second equation by 3. Now let's see why. So the first equation, I could say -2. And then this one by 3. So I have -2 times 5x is -10x. -2 times 3y is -6y. And then -2 times 2 is -4. So then that's what 3 times 4x is 12x. 3 times 2y is 6y. See what I did there? And then 3 times 10 gives me 30. So when I work through it, I've eliminated that one. So I'm left with 2x equals 26. Oops, divide by 2, not x. X will give me 13. So if x is 13, I can plug in to see what y would give me. I can say here, if x is 13, 5 times 13 plus 3y equals 2. Okay, 15, 65 plus 3y equals 2. I'm going to subtract 65 from both sides. I get 3y equals 63. Divide it. I'm sorry, it's -63. It's a -65. So that's 1. -21. Now, for sake of time, I'm not going to go back in and plug these numbers in, but feel free to do that to make sure that you see that, yes, it is in fact a system, a solution to the system of equations.